Okay, let's start with a session on Heartbleed. How many of you are aware of Heartbleed? Have you by any chance heard of a word called Heartbleed in the recent times in your blogs, in Facebook, social media, anywhere? Looks like nobody has heard about it. Great. What a technically updated community. All right. Over the past couple of weeks, um, since April 1st to be precise, the internet has been shocked. And when I say shocked, it has actually been shocked by such a catastrophic security bug which was found in an OpenSSL implementation. That is called as Heartbleed. And this has been something which has been talked about a lot. Lots and lots of blogs have been there. And this has actually been called as one of the most dangerous, most affected security bug in the recent times. So in this session, what we plan to do is we'll give you an idea of what Heartbleed security bug is, how does it become actually a security bug, what are the things you can do to prevent it, and on all those details will be covered as part of this session, right? Sort of a concise capsule where you get everything about Heartbleed, hopefully. So this is something which was said by a security analyst in Forbes as this is one of the most dangerous vulnerability which was found since internet traffic started in the commercial way. So this actually shows you how serious this could be, the amount of impact this one security bug can have on your web applications. The Tor said, don't use the internet for some time until this gets resolved. If you want complete anonymity, you know about Tor. We have already talked about Tor in one of the previous sessions. If you want anonymity, start using Tor, right? So the Tor project suggests you are no longer anonymous in the internet. As long as this bug is not fixed, don't use the internet if you want anonymity. That is the kind of scale at which Heartbleed has impacted the world. So what is this Heartbleed? Is this a flow of the internet? Some of the frequently asked questions. Is this a flow of the internet protocol? We know that this affects security of the websites. But as we discussed earlier in some of the previous sessions, security could be at different levels. It can be at the server, it can be in the software, the admin panels, on the way where the data goes, on your client side, it could be in the databases, it could be anywhere. There are different levels at which security issues can be possible. So what is this? This is a flow of the internet protocol, the IP layer. Or does this affect the entire internet? We say this is such a massive scale. So what? Shall we not use are all the applications affected completely? Are all TLS implementations affected? First of all, this is not a flow of the internet protocol. Internet protocol is completely okay. This is a flow with a software. One software has a bug which caused this entire problem. So the internet protocol as such is safe. Does this affect the entire internet? No. This doesn't affect the entire internet. So what does this affect? This affects only a certain software, and if that software is used in your web server, then yes, your server is affected. Are all TLS implementations affected? No. Now what is this TLS implementations? We'll come to that in a short while. But the answer is no, all TLS implementations are not affected. If you have more questions on Heartbleed, there's a website called www.heartbleed.com. Let me just take it for you. So this is a website which is dedicated only for Heartbleed. The reason why there are lots and lots of security issues which happens every now and then. But not every now and then do you see websites which are created only for this. Now this was created so that public knows what's happening, what is Heartbleed. The information has to go to the people. This has lots and lots of details in it, so this will probably help you answer all your questions. There are lots of questions in there, Q&As. So this should give you a lot of answers if you have more questions on this. Right. Now, how does this happen? We're going to check a little bit of history. Someone called Robin implemented a heartbeat function in OpenSSL. Now, let me first tell you what is OpenSSL. We all say internet is safe if you use HTTPS as the connection protocol. So you log into your banking application, you log into any application, we say HTTPS is safe. This HTTPS is HTTPS because of something called as TLS. That is what makes the HTTP more secure. But in order to make your HTTP more secure, that is in order to implement the TLS, you need another software. And for that, there are different implementations. An open source version is called as OpenSSL. And because it's open source and free, a lot of companies use this. And that is very good actually, except for this bug. And that has a function called heartbeat. Don is already laughing because I talked about open source. And that has a function called heartbeat. Now what is heartbeat? We'll come to that later. But that was implemented by someone called as Robin in 2011. But every source code which goes to, before committing it, before merging it, it usually goes through a series of code reviews. As usual, this was code reviewed by someone else, but unfortunately, he missed the flow. Because it's a very minor flow. This is a very, very easy and minor flow. But it was missed. And that code was introduced into the actual SSL, OpenSSL module in December 31. That is just before the new year. This was merged into the actual source code. And that was released on March 14th. And since then, it has been widely adopted. Widely in the sense, widely adopted by a lot of companies. Your internet ISP, internet service providers might be having hosting solutions. Your hosting providers, they all use it. And different companies come and buy the HTTPS and they get affected because they don't know about it. The servers already have the malicious, not the malicious, the flawed version of software installed in them, right? And when was it discovered? Someone called as Neil Mehta from Google discovered it on April, very recently. That is, if you remember, this was in 2012 when it was merged. But this such a big issue was noticed only in April 2014. Approximately one and a half years, it was all there. It was lying there as such, right? At the same time, this was discovered by another company called Cognomicon. I don't know how to pronounce it, to be honest. But that company came up with this discovery approximately at the same time. And it is this company who created the website called the heartbeat.com, which we saw a little while ago. So they created a website so that people know about this, how dangerous this could be. But the problem is, it is assumed that this was already known a long time ago in the hacker world. For example, a scanner called Masscan, it was released 6 months ago. It had a code to exploit different servers. And that exploit was based on something very similar to this. And if you check the server log and terminates a connection, the way handshakes happen and all, how it terminates a session, everything was sort of very similar to how the heartbeat works. Again, according to Bloomberg News, NSA was already knowing it. So it's all out there in the hacker world. They add it to different rootkits, to tools, and they sell it out. So all you need to do is buy it at a price, run it against a server, and you get all the information. It's being sold. But this wasn't known till very recently. And the fixes, it's true that it was reported on April 1st, but as per some tickets, Google already wrote a patch for it on March 21st. And Cloudflare also released something similar. So chances are there are lots of fixes already out there. So now in the coming slides, we will look at what the bug is and how the fix can be applied to it. Right? Now, how do you detect if your website is having Heartbleed? If it's affected with the Heartbleed problem? There are since this was created, this issue was reported, a lot of people have come up with tools to check for Heartbleeds. So these are some of the tools which you could use. You could use any of this to do a check on your server. So we'll try one of them. It's called this thing, Heartbeat Scanner by the Italian cryptologist Filippo. I don't know what the other name. So this is how it would look like. Let's show it to you. So if you can open the site, it gives you an option where you can enter the website name. So it says that Facebook has been fixed. It's all good as of now, right? So this is one tool which you can use to identify if you are having websites which you host in different places. It might be very good if you can go today, open one of these tools and see if your website is actually having problems. If there is problem, talk to your hosting provider and tell them to fix it, right? Again, it's not just those tools. There are more tools already available. Nessus Scanner, the Nmap, the Snort, Wireshark, TCDump. They all have the modules installed for it. For example, Nessus Scanner, it's added as an extra module. From the recently released version, Nmap also includes it. As for the Snort, it is it is a IDS, intrusion detection system. So SourceFire has released the rules for it. So you need to run rules which will identify if such an attack is already happening to your machine, into your server. So that rule has been added by SourceFire. And Wireshark also now has this feature which you can use. So now let's get into a little bit more of Heartbleed. About Heartbleed, there are, as we said about different XSS injections, SQL injections in the previous sessions, you have to know a lot of stuff for that. In this case, all the privileged information you can get yourself without having to log in, you don't have to do anything at all. You just have to send some packets with some information. It's that easy to do this. So as we talked about OpenSSL. OpenSSL is a software which you use for TLS implementations, and it communicates, it helps in communication for the SSL protocol. Now if you can take a look at this, it shows that this is your Apache server, and this is the green one is your Nginx. So Nginx and Apache are the most affected in this Heartbleed scenario. Microsoft IIS has its own version of SSL that is not, it doesn't use OpenSSL. So Microsoft is sort of safe. When I say sort of safe, even if that is gone to another server farm, and if that farm has another Apache implementation, this could also be affected, right? So Apache owns most of the web, and because of this, this bug affected millions of websites. That is 17% of the websites were affected. That comes to a very big number. Millions and millions of websites were affected with this. So what is Heartbleed? What is Heartbleed? We talked about Heartbleed. Now Heartbleed is the name given by that company for this bug. The bug was found in an extension of TLS, and that extension is called as Heartbeat. And because that extension has the name Heartbleed, he gave the name Heartbleed, right? So what does this extension do? See, normally when you try to connect your internet, before I send a packet to you, I need to know whether that machine is up and alive. It's working or not. It could be dead. It could be off. It might not be there, right? So in order to know that, there are different ways, and Heartbeat is one such method to know it. What the Heartbeat does is it sends an echo request. Now what an echo request does is, it's a very simple logic. I take some packets. I say, I'm sending you some data. You need to echo back to me the exact same data. So that's all it does. Now once you echo it back, I know that it's working. So that is what, yes, OpenSSL server will do, right? So that is called as a keep alive functionality. So you know that your server is already there, it's alive, it's not dead, it's still up and running, so I can communicate with you. Now once I get that, I start sending the actual data. That is how the normal protocol works. So the advantage of this is you don't have to perform a renegotiation every now and then. It makes it much easier. And it helps you understand whether the other party is still out there, right? So that is called as a Heartbeat. So this is how it will work, but the image isn't clear enough. Okay, what? I should have zoomed the image. Okay, one second. It doesn't. One second. a heartbleed issue would work in a very simple terms. Okay. So what we need to know is the server out there still up and running? Only then can I communicate to it, right? So they ask you, okay, are you still there? Which means, are you still on there, or have you dropped off? Okay, and if you're still there, reply potato. So as I said, it's an echo message. So you have to give back that message as such back. So the server understands, okay, Meg, this is Meg. Okay, now Meg wants those 6 letters potato. So it sends back those words, right? So it says potato because that is what Meg had requested in the earlier request, right? Now, after a while, it's trying to negotiate again because after a couple of time, it'll try asking you again and again and again if it's still there, it's still there, it's still there. So this time, Meg asked, "Are you still there? If so, reply bird." So now the server knows, okay, I have to reply back with a message bird so that the other person knows I'm still up here. Okay. So the server says bird. And then Meg gets it. Okay. Then what Meg says is, okay, in that case, reply back hat. And there is an extra option which you provide called the length. How long should the message be? That's an additional parameter. And it sends 500 letters. So the server takes this and says, okay, I have to give 500 letters back. So instead of replying back with only hat, what the server does is, server replies back lots and lots of stuff. See? So what is the heartbleed bug? The heartbleed bug is very simple. It doesn't check the incoming input bounds. That's it. So the question to you as developers is, how many of you code, when you code, actually validate all your input parameters? If not, that is something you should start implementing seriously. We've discussed this earlier also on all our security related sessions. So what this does is, what this could have been avoided, all this could have been avoided if there was a check in the input which comes into the server, right? So because of this, the server reads extra portion, a lot and lot of extra portion, and that data is sent back. The problem is, it is that data which stores all the private details. It could be your session keys, it could be your permanent certificates, it could be your passwords, it could be anything. All those are provided back to the attacker. So this becomes a very serious issue. So that, in short, is heartbleed in very simple terms. Back. Right. So this is how the flawed code would look like. So over here, it takes some data. It's this P when you assign to PL. This P which comes in, this data is from the payload. Okay, the payload which comes in is not validated. So that becomes a problem. Any payload, anything, any data with the user sends to the server, whatever form it may be. We discussed this earlier. It could be in the form of an input string. It could be a user HTTP details. It could be anything. Everything has to be validated, but that didn't happen. So this is the commit. This commit is when the flawed code entered the OpenSSL. I can show you that. Okay, not this one. Yep, this is the commit where it happened. So close the browser. 1 minute. Um, so how is it exploited? See, as we said before, everything boils down to one single line of code, which is this. See, what this does is it's allotting some memory, right? Now, how much memory is this allotting? As much as the payload is. So remember, in earlier case, Meg said 500 letters. So that comes in as such, and it gets allotted to the buffer. So whatever is there, actually this should only go up to 16, 2 bytes. That's 16 bits, right? But because there is no check, it treats the next area in the memory, which is not supposed to be read by this, right? Because there was no bounce check. So what you have to do to exploit this? You take a heartbeat size, make it larger than the expected value, that is larger than 16. 16 is the default which should be sent, and then send it to a server. Because it should be sent to HTTPS, usually it should be in the port 443, because that's where the HTTPS port is. So you send it there, and then you'll receive a response back, and the response will have up to 64 KB of data. So that data will have lots of things in it. Repeat it again and again. So every time you get new data coming in, you get tons and tons of data with you. You don't have to need anything at all. It's just a simple process. There are tools available. One click of a button will do it. There are paid tools. As I said, the mesh scan which we saw earlier, you don't have to do anything at all. This is a very simple exploit, but it is very, very dangerous only because a single integer, a field of length was not validated. Right? So this is how it would look like. So you look at this. When you're trying to access a login page, normally, say for example, a Yahoo login page, every data is sent in HTTPS. Now look at this. This is the data in the hex format, but that you can analyze and see this. What does this say? It says that for the login, see, agnesaduboteng at yahoo.com. That is the username. For that username, the password it's not provided. It's been blacked out. But over here, you get the password. So this data you will get. This is Yahoo. This affected Yahoo, Gmail, Facebook, Twitter, a lot of companies. Now it is not just message. See over here, what are you getting? You're getting a password, right? So one user, you get the password. You do it again, you get lots and lots of such stuff. But it is not just about passwords. Passwords is only a tip of the iceberg. The real jewel is certificates. Certificates of your websites, your web servers. Now what would happen? See, how does your data get encrypted? Every time you need to encrypt the data, you need to have a certificate. And it is with that certificate, you decrypt it back at the other side. So if you have that, because the certificate is only with the web server, only they can decrypt it. And that is why this communication becomes safe, because no one else has that certificate, no one else can get the data from it. However, in this case, when you get the certificate, what is happening? Every data which is sent to your server can now be decrypted because the certificate is now with us, right? That's not enough. That's not it, because this is the sentence. See, the issue happened only in December 2011. But if I have the certificate, I can even read messages in 2009 or 2007 or 2008, even long before it, because certificate might not have been changed. So that becomes even a bigger problem. Right? So every message sent to that server is now affected, and it can be read. So that is a very, very, very big problem. All the past messages can be decrypted. What is the fix? The fix is you're checking the bounds. See? You're putting in checks in there. If it's not there, don't do it. If it's less, allot it into the memory. It's that one check which is enough to fix it. So this was a fix which was released. So what happened is when this was found, a lot of companies actually started doing this. They started fixing OpenSSL by themselves, and then they recompile it again and they do it. That was one option, but now fixes are it's all available. So how do you know if you're already exploited? You have no idea of knowing it. You cannot know. Why? Because your logs might not show anything. Say for example, you're trying to do an XSS injection, or you're trying to do an SQL injection. If you check your access logs, you can see that there are lots of HTTP requests over there, some strange sort of request. If you're trying to do a directory traversal, if you're trying to do some sort of trying to find out if particular directory is there, denial of service, fuzzing, all those will show up in your logs. But this is not something which might show in your logs, right? So it's difficult. Or you have to specially log it. But this area, it's not there. The handshaking protocol, it gets disconnected. Those part, logging, it's not there usually. Is it only for websites? No, it's not only for website. This affects everywhere you use OpenSSL. It could be in your emails. It could be in your instant messages, your VPNs, anything where you have OpenSSL implemented, it is affected. So it doesn't mean that you check the URL and see HTTPS there, it might be affected. Even if you don't have HTTPS URL in there, it could be affected because the implementation on the server side might be using a version of the OpenSSL, right? Before this, so something I didn't include. This affected a version called 1.0.1. That is the version of OpenSSL which was affected. All versions are not affected. So versions from 1.0.1 to 1.0.1F are affected. The fix is update it to a next patch. Yes, update it to FG. Yes. So update it to 1.0.1G, and that will help you fix it. That's one way. If not, you can recompile the OpenSSL and disable the heartbeat. So it'll work in another way. Now to disable the heartbeat, there's a switch. There's a small thing you have to give. That's called this. DOpenSSL, no heartbeats. So once you do this, you have to recompile it again and then set it up. That's another way to do it. But that doesn't help because past messages already had the other things. Your certificate is also the same now, so that could be a problem. Chances are that certificate is already there with an attacker. So you have to change your certificates. The key which you have, it has to change. And whatever sessions you already have, that has to be expired as well, just to make sure it's safe, right? So that is what you have to do if you're a system administrator. If you're a developer, what you have to do, you have to learn to code securely. Whatever it takes to code safely, you have to learn, study, and do it as a developer. That is what, as a developer, you can do. As a normal user, go change your passwords in all the sites wherever possible, because there's no way of finding out it's already lost or not. So change your password in every place. Go home today, open Gmail, Facebook, Yahoo, Twitter, whatever you have, go change the passwords. So that's pretty much about Heartbleed, what Heartbleed is, the history, how it affects, what is the fix, everything about it. So any more questions on Heartbleed, please feel free to ask. If I know it, I'll answer it. Otherwise, I'll get back to you with the answer. But in a common terms, in a very simple term, the Heartbleed is simple. The server sends a message, it is not validated, it replies back with as much length as the other attacker requested. But that space, because it contains the secret stuff, the stuff which is not supposed to be public, those details, sensitive details, that get back to the attacker. That's it. That is Heartbleed. So now I hope, at least when you came here, you didn't know what Heartbleed was, but at least now you have a very basic understanding of what Heartbleed is. Tomorrow you go somewhere, people talk about Heartbleed, you at least say, all right, yes, Heartbleed, yeah, I know what it is. Right? So I hope it was helpful. Any questions? Thank you so much for this coming here. So please feel free to talk to each other, know each other. You all know this, you don't have to talk about this in every session. So thank you so much. See you next time. Bye.